For the given polynomial function f, whose equation is shown, we need to list all of the possible rational zeros, then find all of the zeros of the function and write the function as the product of linear factors. This is a fourth degree polynomial function. From our previous knowledge of polynomial functions, we know that the right end is going to go up because it has a positive leading coefficient. We know the left end will go up because an even degree function, the ends will match. We know the y-intercept is 16 because that's the constant term in standard form. We know that there are at most 4 real roots. But we also know there might be less than 4 real roots. If there is one complex zero, there will be another one because complex zeros come in pairs. So these are some of the things that we already know. What we're going to do is we're looking at the constant term, which is 16. We're calling this P. We're looking at the leading coefficient, which is Q. And that's 1. Now we're listing all of the factors of P and all of the factors of Q. And in particular, we're interested in P over Q. And these are the possible rational zeros. So there are 10 possible rational zeros. And what I could do is use synthetic division, divide all 10 numbers, divide the function by all 10 numbers. And if I get a remainder of 0, that will be a 0 of the function. So we're going to go ahead and set up our synthetic division. And along the top, we're going to have the coefficients of the given standard form polynomial. And my favorite number to divide by with synthetic division is 1. And I will know that 1 is a 0 of the function. I will know the function passes through 1 if I get a remainder of 0. So how synthetic division works, we just bring this straight down. Now we multiply these two together, and then we add these, multiplying -3 times 1, adding. We continue this process. -11 times 1 is -11, and this has a remainder of 5. Now that's significant because that tells us that the number I divided by 1 is not a 0 of the function. That is to say, this function will not pass through the point 1, 0. In fact, it will pass through the point 1, 5 because the remainder theorem says that whatever you divide by, the remainder is the y value at that x value. So I want you to picture this function in your head if you can. And we don't know a lot about it right now without a graphing calculator. We know it goes through 0, 16, and we know it goes through 1, 5. So it feels like it's tending in this direction. So maybe if I try 2 as my next 0, that might give me a remainder of 0. So let's check. So once again, P are all of your factors here of your constant term, Q plus or minus 1, the factors of the leading coefficient. P over Q are our possible rational functions. We've already tried 1. 1 doesn't work. There's 9 more that we could try, but we're going to try 2 because we were kind of visualizing this function. So here are our coefficients, and we're going to divide by 2, and we'll bring this one straight down, and 1 times 2 is 2, and then we're going to add. Of course, we multiply -2 times 2, and we add. Multiply 4 times 2 to get 8. When we add, we get -8. And look what happens here. We do get a remainder of 0. Okay, so that's a big deal. What does that mean? That means this function will pass through the x-axis at 2. That means that x minus 2 is a factor of this original polynomial expression. So because of that, we're going to rewrite the original expression in factored form. But the only factor I know so far, the only linear factor I know, is this x minus 2. And what's left, how I got this expression, was I had 1x cubed minus 2x squared plus 4x minus 8. So what we do next is we look at this cubic expression. And I might have to do it again. I might have to actually go through that process of synthetic division again, but what I'd rather do is observe the fact that I believe I can factor this one by grouping. So I think I'm going to use my box strategy. And I'm going to write x cubed minus 2x squared, and then 4x minus 8. I'm going to factor out of the top a common factor of x squared. X squared times x is x cubed. X times 4 is 4x. And x squared times negative 2 is negative 2x squared. And just to be sure, 4 times negative 2 is negative 8. So I've taken what was this cubic polynomial with 4 terms, and I've factored it into 2 terms, one of which is a linear factor. The other one is a quadratic factor. So this is another big deal because this tells me that the function passes through the point x equals 2 with a multiplicity of 2. So it actually bounces at the point 2 on the x-axis. Now, how do I get the x value that makes this part 0? Well, what if I subtracted 4 from both sides? And I got x squared equals negative 4. Then I took the square root of both sides, and I got x equals plus or minus 2i. That tells me these are imaginary solutions, complex numbers, right? So really, the only place this curve is going to hit the x-axis is at the number 2. It's going to bounce there. And if I had to write this entire function as the product of linear factors, I'm going to write x minus 2 quantity squared. And I'm going to rewrite this expression as x minus 2i and then x minus negative 2i. And I believe I have answered all of the questions. I listed all of the possible rational zeros. I found the zeros of the function. The zeros are 2. It has multiplicity 2, 2i and negative 2i. And I've written the function as a product of linear factors.